again at Banggood an Aneng multimeter, this time the Aneng B01 pen type digital multimeter auto range true RMS NCV 6000 counts AC DC voltage resistance capacitance temperature tester electronic meter. As mentioned before, why they use so long names. It's Aneng B01 and then you can write it smaller underneath, something like this. I don't like it when it's so long. Yes, I bought it about $18. I think it was a little bit cheaper. It was on the pre-sale when I bought it and it just arrived 2 days ago. But the video take a while because I catch a cold. So today, if my voice sounds different or if you hear some noise coming from my nose, I'm sorry for it. So, I didn't open it yet, but I was surprised when it arrived because it comes in a box. That is really unusual. Never get it in a box yet, so this is in a box this time. The box is not very nice. It doesn't show me Aneng outside. And I already found some of the meters like the AN8008 with different names, but I think Aneng is the main brand, but I'm not sure. So what we need to do today, just unpack it and then open it. And after we open, we test it. And always at these meters, I have to be honest, I don't trust them that they are, I think somewhere they wrote Cat 3 rated 600 volt. I don't think so. I don't think that is really Cat 3. But I'm using all the stuff for up to maybe 50 volt, and that is really seldom, really not often happen that I use more than 50 volt, or even 50 is very, very seldom. Most of the time I'm using about 12 volt and less. Yeah, it comes with a small user manual in English. Wow. Whoever want to read, I'm not interested in this, maybe later. And it comes in a nice bag again. Let me make the smell test. Oh, even my nose doesn't work so well today. I have to tell you, this time the bag doesn't smell. The other 2 meters from Aneng I got, the bags smells terrible. Remember the discussion on the other videos. Yeah, there's the pen type multimeter. I do it like Dave. Okay, it makes noise when I crack it really hard, but it looks stable. Very nice. Then what else is inside? Empty bag. Have a look. Empty. Yeah, what else? It comes with 2 leads. 1 lead ending in a crocodile clip. It has to open. Brute force always work. I could search for the knife or a scissor, but brute force also work. The lead doesn't feel so bad, but I think we will test it with my method I show in another video to check the quality, because I don't have any really good milliohm resistance meter that can measure in milliohm range. So I will using 10 amps, no 5 amps, and send it through the cable and see the voltage drop on the cable to check the quality. But doesn't feel bad. It's, of course, it's not like the good quality ones, and I still really want to test one of these Probe Master leads, but I didn't find any way to order it in Germany. Only one very weird one with 1 lead and then 2 leads come out, like, yeah, where's something to paint here, like the one I found looks like this. It has 2 leads on this side with the banana plugs, then it goes to 1 lead and then open again to 2 probes, and doesn't look like the golden probe. So, and it's 50 bucks, so I don't want to order it. So back to the Aneng B01. Oh, I forget the name already. No, B01, it's right. Yeah, that is how it looks. And that's the rest that was in the box. Cables, 2 cables, 1 normal test lead with a probe, quite sharp, and an alligator clip. Doesn't look so bad. And the box. Wait, I have to arrange it nice for the video intro picture. And the user manual in English. Yeah, that is in the box. Next step, we don't switch it on. We take it apart, have a look inside, see what's going around. Yeah, we are back, ready to disassemble the Aneng B01, and I tried to make it standing, so yeah, I have better control over the video, that I don't go out of focus. I need to think about it. So I'm using my Xiaomi Weha tool. Okay, doing this while standing is not the easiest way. Metal threaded screw for the battery holder. Oh, comes out. Oh, here what does it say? Warning: to avoid electrical shock, remove test leads before replacing battery or opening case. No, it's okay. Should know this. Then it says serial number. I don't think that they produce so much of it. I think it's like a random number. Yeah, look at it. 738162561 73 millions. I don't think so. And what does it say in the front? Here, 600 volt, 600 Cat 3. I'm not sure. And yeah, this comes out if you want longer. And it's really sharp. I have to be careful that I don't cut myself. I'll put this back. So what else we have? 1, 2, 3. 1, 2, 3, 4 screws. I don't think that they are metal threaded. And these are self-tappers. Yes. 1, 2. I'm wondering if they also use the tiny fuses that I use in the Aneng AN8008 and 8008 we see in the previous videos. We put the screws away. So let me see if it's ouch. Just press myself. Okay, I think I should move this first. This. Okay, maybe I should sit down. No, I got it open. Yeah, here. Oh, nice. They have the contacts for the battery on the board. And yeah, board construction on the first glance doesn't look bad. Plastic quality also doesn't look bad. So what do we find inside? Yeah, the tip is in the front. They have a small 3mm LED there. And that I don't like, to be honest. This quality of this soldering or the cable inside is really not the best. I try to show you. Yeah, you see very thin lead inside. Well isolated, but the soldering doesn't feel good of the cable, and then also here when it goes to the tip doesn't look nice. Maybe this has to be removed. And I try to zoom in. Wait a second. Oh, that is the best my camera can do. Oh, to be honest, I'm using iPhone, not a camera. So what I didn't see on this side is a fuse. I really have to sit down. Sorry for this, because my eyes are not the best. People seeing my last soldering video will say I have better eyes than them. Yeah, what do we... No, I didn't see the camera. Damn it. Okay, if I keep it here, you should see it. Yeah, what do we have here? We have two 5 mega ohm resistors as for the high voltage protection path. Yeah, 2 is better than 1, but in good brand multimeters you see a long line of maybe 250Ks or 1 meg resistors doing the same. What I didn't see here is any fuse, but I remember they wrote before replacing battery or opening case. Doesn't show anything about a fuse. Does it have amp? No, they have. Oh, it is also only volt. Okay, but does it make sense without a fuse? You won't put a fuse inside? Maybe that's why. But we have one PTC, so we have a little bit input protection. And because it doesn't have any amp range, doesn't have a fuse. There's the main switch cut out in the board, coming through the other side. And that is maybe because of the size of the switch. So soldering quality doesn't look bad, only here some solder residue, here very bad solder residue. And then yeah, chip on board, 4 megahertz crystal, and a small chip here. I should get out the, I have something for it. Oh, wait, there. Oh, need to be cleaned. It's a little bit dirty. Maybe we can find out what chip this is. You doesn't see that this happened, okay? It has also a little light. The light goes to the wrong direction. To be honest, I cannot see any. Chip, tell me your name. It's a P24CO2A. Should write it down somewhere. No, doesn't matter. Someone will look for it. I have no idea. For me, it looks like an E-Squid Prom. Not sure. So, another screws to open. Go ahead, open this thing. Take it apart. Look at the rest of it. The black screws need to go to another place. Maybe there. I should take it apart like this. Maybe I should zoom out. Sorry if you get dizzy. Yes. Okay, I think that is not bad. So, yeah, the binding, no, the post here doesn't look so bad. I remove 3 screws. So 1 screw will be left after closing down this thing. Oh, and it's held by some plastic clips there. Just you need to get out another bit. By the way, people ask me if the Xiaomi Wiha kit is compatible with the something called Wow Stick. It looks like a mini electrical screwdriver. I just bought one some days ago. Should also arrive soon, and then I will check. Really, I don't know why we need small like this as electrical, but oh, comes out. Why not? It's cheap. So there we have the back side of the board. Nothing there. I don't want to remove the LCD screen. Oh, I already opened the screws for the LCD screen. Put it back. Sorry. It was not holding the board. It was holding the LCD. Yes. Don't see this. Okay. Here, just put it back. Because I think I read it has 100 rounds per minute. With my fingers in turning, I think I make more than 100 rounds per minute. It's very slowly. So, put it back. Yeah, because nothing here on this side. Really empty board, not much populated. Switch doesn't still work. This is still in place. Oh, one deeper. Yeah, the build quality doesn't look so bad, to be honest. We have a little bit input protection with the PTC. So if the voltage gets too high, this will get low resistant, but there's no fuse. I think a small fuse should be there, even it doesn't make amp, but I'm not sure. I'm not a specialist in this. And but the nice 3mm LED, so I can change the color if I want. Don't know the color yet. Maybe a red. Oh, that is a little bit difficult to get back in position. Yes, look like it's there on the cable. I will route around there. So that's all. I put it together. You don't need to see when I put it together, and I come back with the testing. So, time to power it on, because I already tried it and messed up the first video again. You have to press it long to switch it on. That was the first mistake, I pressed it short. And then the red button is also to select. It says power on and select. So first, when you switch it on, it is on DC. Now it's on AC, 2 amperes, millivolt, kilo ohm, also ohms, continuity, diode, capacity, and hertz. I didn't find any temperature thing, so it was written temperature on the first page. The rest is hold, range, and relative. So if you want to reel out the test leads for ohm measurement, you can do it here. This one select the main ranges between millivolt and the diode tester. And if I press it, it comes out. It shows here in the display. And then it runs in volt mode. DC AC, of course. You press switch it here. And then hertz. When I act like an antenna, we get to 50 hertz here. And the electric field. This one I don't trust, so I tried already. I bring in 220 cable here. It doesn't show. No, on this side it shows. Sometimes it shows on this side. Now it shows on this side. At the moment it doesn't work so bad. Maybe it depends on where you switch it on and which position. So to search a cable under the wall, I will still use the special toys for it, not this. Okay, so you see it starts with, maybe I'm charged to 1000 volt, I don't know. DC again, but we will start the measurement in DC millivolt. So I bring in my Unity 61E. This is still my most precise meter I have. I hooked up the test leads here, my own one, good quality, and set the banana plugs parallel here, so you can just plug it in the back and in the front. Because it's a 6000 count multimeter, it should show me something with 5 starting. The Aneng is 20,000 count, so it counts, so it shows 0.591 millivolt here. No, maybe you can get 1 digit more. No, we have, that is too much. So we have 591 millivolt on the Aneng B01 and 589 on the Unity. For me, that is okay. I don't, how to say, calculate now the failure because I don't even know if my Unity is in specs. So for me, both is enough. 5.9, 590 millivolt about. So yeah, bring it up to, yeah, when I go to let me see, when I go to about 700 millivolt, you see the Aneng already shows overload because it's only a 6000 count and millivolt cannot show more, so I have to switch here, and it shows 0.694, and the Aneng the Unity is still in millivolt range or in volt range and shows 6914. So about this is 600 millivolt, 90 millivolt, 1 millivolt. It's about 2 millivolt difference between these twos. And now, just for kicks, I go to, let me see how much I can get out of this power supply. So I set it up to 10, and yeah, the Aneng shows 10.07 and the Unity shows 10.052. So we have 150, we have about 18 millivolt difference between these twos. And I think I still can go to 20. Yeah, we have 21.5, 21.4, 21.5 and 20.11. So this is already 40 millivolt out difference between these twos, but for me 20.15, it's still good enough. What else can I check here? No, this is enough for the voltage range. For me it's enough. Should switch it off first, but 20 volt doesn't kill doesn't kill me. So next one to test. Test some resistors. Plug in the test lead here. Let me see, I have to switch back there. Yeah, it's a little bit weird to use, but I think most of the time I will use it to test voltage, because for testing resistors, don't think that, oopsala, hey, stay in my hand. Okay, I don't like it already. So yeah, for resistors, it's really not the best. The Aneng shows 80.9 kilo ohm, and my Unity doesn't show any yet because I didn't bring it in. My Unity will show 80.82. Yeah, that's okay. Maybe another one, just random picked from the bench. The Aneng shows 8.5 ohms. Can you see 8.5 ohms? And Unity, no, it's not the best way. 8.5, 4, yeah. Okay, for me, ohm, good. So what else? Delete. Don't like it. Yeah, and it has backlight. That is something I really miss at the UT61E, that they don't put the backlight in. I know there is. Oh, very bright. Yeah, backlight is nice. And we have the little flashlight in the front. Wait, I need to switch off the video bench light. Wow. Yeah, that is a little bit crazy. Whoa, I can find wherever I touch now. I can measure in the dark. I can measure in the dark. Is it crazy? Yes, it's crazy. I can measure in the dark and you don't see any, because it's too bright to display at the moment. Okay, let's switch on the video lights. Oh yes, I have new lights for the videos now. Yeah, switch it off. I think that is really enough. No, one part still to do. Test the resistance of the lead. So back soon, just need to set up something, and it will be a little bit noisy because I need a 5 amp power supply and the fan in it is a little bit loud. So I set up the measurement to test the probes from the Aneng B01, and I wrote paint a schematic for you, because last time I do it, people ask, is it precise, or you don't have mentioned about the resistance of the meters or the leads, the probes you're bringing from the power supply to the meters. And I want to show here that it, of course, it plays a small role. But it's so less, doesn't matter for me. And to compare the cables, it's okay. The trick is, I don't measure the output voltage of the power supply. So if I measure here directly at the power supply my voltage, then all the cables here, all the things here will playing a role, will be in the measurement. But I measure the voltage drop over the probe under test. Most of the amps go in the probe under test, and the only a little bit of energy of amps will go through this meter and through these cables. And so these amps will only measure the amps that goes down the probe under test, because probe under test is something in milliohm range, and the meter will be something in mega ohm range. So because of Ohm's law, this doesn't matter. Of course it matters if you want to be very precise, but for me it doesn't matter. Here I only show you how I set up my power supply. I set it up to 10 volt and limit it at 5 amps. I think that should be enough. Yeah, I don't have more than 5 amps. With 10 amps would be more fun, or with 50 amps also more fun. Maybe I can get a big wire to smoke. Yes, so that is the setup. I will start with one of my own test leads I built, or with my own leads I built. So just make the contact here. Make sure you have good contact. Should I do it? Yes, I do it. So, looks like I should switch to volt range. It's millivolt. Doesn't work here. So, what do we get? It's jumping around. I think maybe the contact is not the best here. No. So, with Singer's cable, I have, in the worst case, maybe it's running out of battery, 170 millivolt at 5.159 amps. It's getting up. The resistance go down. Maybe it's because of the cable is heating. I'm not sure. Someone can help me out maybe. So, switch it off. Now I'm going to one of the cables that comes with the Aneng. I start with the alligator cable here. Make sure the contacts are clean. I know it's not the best way to connect them together. So it will also play a little. Plug in there. Power on. But I tell you, it's for comparison, it's not bad. The crocodile lead has about 460 millivolt drop at 5.167 amps. So switch it off. Now this one. And this one really want to agony me. Don't know. Let me think. It is quite tricky now. I should hold it. So hopefully I don't burn myself. Whoa. And this is the worst cable. I write probe on it. Don't worry, it still doesn't get warm. The probe is 630 millivolt at 5.170 amps. So, time to make some measurements. Get away those things. Now it looks messy. Yeah, where I get a calculator. Wait a second. Oh, I found the old ts.82. I think this is a little bit overkill for this, but doesn't matter. The phone is taking the videos, so I can use it as a calculator. But I found this. So we have 170 millivolt at 5.159 amps. This is 0.170 divided by 5.159. And we have a result of 32.9. Not enough place to write. Sorry. Maybe go about there. Milliohm. Yes. Okay. Then we have 0.460 volt divided by 5.167 amps is about 89.0 milliohm for the crocodile cable. And now to the worst one, 0.63. Yeah, there's a point, okay? I didn't have the 0. Divided by 5.176 amps is about 121 milliohm. That is really high resistant cable. And I can show you this with the Unity. I already tested, I could not believe. I think maybe I make a measurement failure. But here you see 120 milliohm. So my method is not wrong.